Hello everyone, we can see the topic of fundamentals of robots. Topics to be covered for the following topics. So first one is what is robot, that second robot definition, third one is comparisons of human robot, fourth one robot anatomy, fifth one is different types of robot anatomy, then sixth basic robot motion, seventh one is different robot configuration, then eighth one is specifications of robot, ninth one the parts, robot parts and their function, finally robot roles of the industries and also another name of applications of a robot. So these are the topics to be covered today, right? So we can see one by one. Robot, what is robot? The meaning of robots we can see now. An electromechanical device. It is an electromechanical device which is carried to perform the various tasks controlled by the human or automated. Okay, so it is called as a robot. Then next one is robot definition. So this is a robot, the reprogrammable and multifunctional manipulator, which is designed to the work is carried like move material, parts, tools or any other devices through various programmed motions for the performance of a variety of tasks. Okay, so this is the robot definition, right? Another one is comparisons of humans and robots. So now we can humans, we are five and six types of process we can carry it, like brain and skin, ears and nose, eyes, arms and hands and feet. These are the human parts carried by the work regularly. So like also we can use by the robot also, we can same process of work they have to carry it, right? Okay, so we can see in one by one. So brain, it is used by the human, we can thinking and we can use to create the parts or innovative things we have to use to create the brain. And then robots, we can use the processor and also we have to connect it by the automation process, so computer chips and softwares. Okay, then skin as a nose by using the human, and also we can use by the robots by using the sensors. Okay, so the lights and sounds easily detected by the sensors by using the automation process by the robot. Eyes, we can use by the humans, easy visioning systems, so we can use by the robot also. Vision system for using by the works with the cables and TVs and cameras. Then arms and hands, so the end effector, the manipulate and support tools we can use by the automation process. Then finally the feet, by using the human we can move it one place to another place, which is called as the transportation system. And also we can use by the robot, we can use by the some of the movement mechanisms we can carry by the automation process by using the robot. Okay, so this is the main comparisons of human and robot. Next one, robot anatomy. Robot anatomy is concerned with the physical construction of body, arm, wrist of the machines. Okay, so these three are physically connected with the robot, which is called as a robot anatomy. And then which is mounted on the base, which is fastened to the floor. Then another one is usually involved either rotating or sliding motions. The entire assembly of body, arm, wrist of the machine is called as a manipulator. So the manipulator is main part of the robot, which is carried by the work from the robot. Then automation, which is connected by the robot hand or tool, is called as the end effectors. Okay, so finally the work carried by using to the tools in another name of the end effector. Next slide. So this is the diagram of robot anatomy. So we are this basically we have to see by the base from the bottom and the shoulder, they have to connected by these some joints, and we have to connected by on another one joint which is connected which is the name of elbow, and another joint which is connected to the wrist. So finally we can use by the tool or end effector, right? So this is the diagram of robot anatomy. And also another one diagrams are shown clearly, we can use to the type of motions. We can use it to the 6 types of motions. Basically for first one is rotational transverse, then second one is vertical transverse, third one radial transverse, fourth one is pitch, and fifth one is yaw, and sixth one is roll. Okay, so these are the transverse methods we can see in future PPTs. So there are different types of robot anatomy, 4 common configurations. So polar configuration, cylindrical configuration, Cartesian coordinate configuration, joint arm configuration. So then another name of SCARA, which is called as the selective compliance assembly robot arm. Okay, so 6 basic robot motions are, so we are seen in previous robot anatomy. So that is the movement, so I will explain here. So the rotational transverse, the movement about a vertical axis, radial transverse, that is the extension or retractions of the arm, vertical transverse, up and down motion. Okay, so these three works carried by the arm of the robot. Another one, pitch, yaw, roll motions. So okay, so these 3 motions we can carry it by the wrist. Okay, so like pitch, which is called the up and down movement of the wrist, then yaw, which is called as side to side movement of the wrist, and then roll, which is connected to the rotations of wrist. Okay, so these are the 6 basic robot motions are there. So basic robot motions are clearly shown in the diagram. Base will be connected to the arm and body assembly, then rotational transverse, then connected to the arm, and radial transverse, which is connected to the arm to wrist, and wrist they have to assembly, they have to connect it to the end effectors. Okay, so these are the six types of 6 types of motions they have to connect this robot motion. Then different robot configurations. So first one is cylindrical configuration, Cartesian coordinate configuration, polar configuration, joint arm configuration, then SCARA robot, the meaning of selective compliance assembly robot arm, then serial manipulator configuration, then parallel manipulating configuration. Then cylindrical configurations, which is used to the vertical column side, and also they moved up and down to the column. The following movement which is able to perform by the robot, the rotational movement which we can carry by the body, then vertical movement, and also they carried by the body of the robot, then horizontal movement which is carried by the arm of the robot. Okay, so vertical movement we have used to y axis, then horizontal movement which is carried by the x axis. Then application of the cylindrical cylindrical coordinate system. So material handling, then loading and unloading, then palletizing. Then second one is Cartesian coordinate configuration system. The 3 perpendicular slides to construct x, y, z axis. So the following movements are to be performed for the robot. So the vertical movement and horizontal movements we can use by body and arm. Z axis we have to use by the wrist. Okay, so previous one which is difference between the Cartesian coordinate system. So vertical movement we have used by the y axis, then horizontal movement we can use by the x axis, which is used to the arm. The application we have used to the assembly, inspection, loading and unloading. Then polar configurations are spherical coordinate system. The arm can be raised or lowered about the horizontal pivot. The following movements are able to perform: the rotational movement body, then spherical movement joint, the horizontal movement arm. Okay, so these are the polar configurations for spherical coordinate system. So the applications we can use here: the machine assembly, injection molding, then machine tool loading, handling of heavy loads. Then fourth one is joint arm articulate configurations, made up of the rotating joints. It perform as a human arm. Okay, so we can use it by the human, we can use it at any work. Okay, so that is the concepts we have used by the jointed arm or articulated configuration by using the robot, right? Then applications we have to use by the arc welding or spot welding and automatic assembly. Okay, then another one is the SCARA robot. Here rotational arm or linear arms motions occur. Works are cylindrical volume. Robot have 4 joints, with each joints has one single DYF. Okay, so 4 joints they have to connect it in each single DYF by using this SCARA robot. So this is the SCARA robot diagram. Base they have to connect 3 joints, and one linear motions. Okay, that is the meaning, that is the diagrams clearly showing here. Joint 1, joint 2, joint 3 and joint 4 by using a linear movement. Okay, 3 joints we have used by the rotational movement. That is the concepts of SCARA robot. So the application process, the packaging, palletizing, assembly operations we can carry by the SCARA robot. Then serial manipulator configurations. Here the several links are connected serially to given motion end effectors. So we have to easily carry it by the work by using end effector easily, right? So this is the serial manipulator configuration. Then work volume space we have to connect it by the reachable with help of the end effectors. The most types of have 6 degrees of freedom, so which is the important for the environment to the work easily, right? Then seventh one is parallel manipulative configuration. So the mechanical system, several computer controlled serial chains, which is single platform or end effector. So it is made up of closed loop chain. Okay, it is made up of closed loop chain by using the manipulator configuration of the end effector robot system, right? Then another one is the specifications of robot. So it is very important role we have to selecting by the robot. Before these are the specifications easily applicable, we have to select the robot easy quickly, right? So like the accuracy, precision, repeatability, reach, resolution, speed, weight, distance to be moved, then degrees of freedom, payload capacity, stability, center of gravity, then work envelope, then pitch, yaw, roll motions. Okay, so these are the specifications of robot, very needed to essential to select the robot. Then robot parts and their function. So which is main components of robot. First one is body, power drive system, controller, then main manipulator, then sensors, end effectors and CPU. So these are the main parts and their functions by using the robot systems. So body, it may be any shape, size, depends upon the tasks to be performed. Power supply or drive system, the movements of the body, arm, wrist, robot are determined by the power drive system. Then controller, which is a processing device whose inputs both decide and measure. Okay, then manipulator, fourth one is manipulator, which is used to manipulate the materials without direct contact. So that is the meaning of manipulator. Then it contains links, joints and other structural elements of the robot. The sensor, it is the electronic device that transfers a physical phenomenon like temperature or pressure, which is connected into the signals, directly signals from the electronic devices. So the vision sensors, the object recognitions are the recent areas of the sensors development. Then end effector is attached to the wrist of the robot arm for performing the various tasks. So that is tools include grippers, pump, blow, torch, weld and spray paintings. Okay, so by using the end effectors that carried by the works easily by the help of end effector of the operations, right? So the working of robot, so what type of inputs you give, the inputs that carried by the CPU processor, finally you can get output of the robot carried by the work. So that is the working of robot. The working of robot, the diagrams are clearly showing here. First one is power supply. The power supply, the processor, they have to connect it to the controller, and again the controller they have to connect it to the base of the robot. Every controller MCU controller units give the input and easily work to carried by the robot. That is the working of robot. Then final topic of this today topic, the role of robot in industries. So machine loading and unloading, pick and place process, then palletizing, arc welding and spark welding, then spray painting, assembly unit, then car manufacturing, inspection section, then packaging. Okay, so we can see in few topics for the applications of robot. So we are using loading and unloading. The robots will be used to move work parts or from the production machines. So this is the applications comes under the category of material handling. So this is the machine loading and unloading. So the machine, it is the diagrams are clearly showing here. Loading process. So shoulder and gripper and workpiece. The workpiece they have to input in the machines, input in the machines. So that is called as a loading, the process of robot machine. Okay, right. Thank you. We can see in the next class.